Hello, can you hear me? Okay, so you can see my screen, is that okay?
You can start.
I can start? Okay, thank you very much. So, let me see whether I can get this away. Okay, so good morning everybody, I hope you can hear me and that my screen will be visible on your big screen over there. This is Ed Simons speaking from the Netherlands, from Radboud University. I'm sorry not to be able to be joining you this morning, but let's see whether we can get the message through this technical media. In my presentation, I will tell you something about an organization of which I am president. The organization is called euroCRIS, and also about what you could call the main product of the organization, which is CERIF, which stands for Common European Research Information Format. So the presentation is divided into two parts. Firstly, I want to tell you something about the euroCRIS organization, and in the second part I will deal a bit more in detail with the CERIF data model. In between, perhaps, I will have a short break in order to allow you to put some questions, should you have any. So let's start with euroCRIS. So what is euroCRIS? Well, we could start with looking at the name euroCRIS, and this name has two parts, which is Euro, that of course refers to Europe, where the organization was established and still has its base. And the other part of the name is CRIS, which is short for Current Research Information System. Sometimes also the shorter form RIS is used for Research Information System. So basically euroCRIS is a European-based organization dealing with or focusing on CRISes. Now Europe, of course, what Europe is needs no explanation, but I'm not sure whether all of you in the audience are familiar with the concept of CRIS or with the word CRIS, so perhaps a bit of more explanation of this concept is necessary. So let's look a bit more detailed into this word or to this concept CRIS. So what is a CRIS? To put it in one sentence, a CRIS is an information system that holds a broad range of information about research. In other words, a CRIS holds metadata on research, because metadata can be defined as data about data. So CRISes store data about research. So if we zoom in a bit more on the kind of information that is stored in a CRIS, then first of all there is information about the research itself or the research projects. Information such as the title, the description, the duration, the academic field the research belonged to, the language used, the level of the research, the participating institutions, the partners, etc. Secondly, there is a lot of information about the people involved, so the researchers, of course their name, their affiliations, the role in the research, whether they are principal investigator, author, reviewer, etc. There's also a lot of CV-related info, like the age of the researcher, the field of expertise, the educational background, the awards the researcher has received, etc. A third component of the information concerns the organizations involved in the research, the institutions and the institutes. Again, their role and position in the research, whether they are funder, leading unit, etc. The type of organization, whether they are a university, research institute, network, contact info about the organization, partnerships, etc. Excuse me. An important part of the CRIS information concerns the input for the research, and this goes about the amount of money invested in the research, the investment in time or personnel, what we call full-time equivalents, but also the equipment used in the research, the infrastructure used, the services used, etc. And of course, a big chunk of information is about the output of the research. So in CRISIS we have very detailed bibliographical information on publications, but also metadata on data sets, on patents, on awards, or any other product that came out as a result of the research. Then, lastly, there is information in the CRIS about who is allowed to use the information and under which conditions. So, what you could call user or authorization rights, distribution rights, etc. So there is information about all these objects or entities there, but also important is there is a lot of information about the relation between these objects. So, to get a proper idea about CRISIS and their function, a bit of history could be useful. Well, CRISIS, or the development of CRISIS, started off somewhere at the end of the 80s, beginning of the 90s, when in some European countries, mainly due to an increasing strain on the financial means for research, governments decided or put a question whether the taxpayers' money for research was properly spent. So, to check this, these governments set up research reporting procedures or protocols, asking the institutions for information about their research. In reply, and in order to register and supply the necessary information to the government, CRISIS started to be being developed and implemented at the institutions. And in the course of the 90s, well, this is a very rough time estimation, but in the course of the 90s, more or less, this model was followed by more and more countries in Europe. So, from the years 2000 on, CRISIS gradually grew into what you could call multifunctional information systems. So not only useful for reporting and administration, but also for providing researchers and institutes with functions for optimal communication and profiling of their research to all kinds of stakeholders. And this is what this picture here shows, where you see the CRIS in the middle, and around the CRIS you see all kind of groups of stakeholders who can benefit, or who actually benefit from the information stored in the CRIS. First of all, the researchers themselves, for instance, for finding collaborations or for generating CV information, but also the decision makers, the project managers, publishers, for finding reviewers, for instance, education, the general public, for getting information about research going on in general, media, small and medium enterprises, intermediaries of brokers of research information, research organizations themselves, for instance, to back up or to support their research policy, funding organizations, of course, for checking whether the money they invested in the research had been adequately spent, etc., etc. So you see a whole world of stakeholders around CRISIS, for which the CRIS is very useful and holds very useful information. So this evolution or development of CRISIS into multifunctional sources of research information is also reflected, or has its parallel, if you could name it like that, in the research information systems landscape, and where CRISIS more and more obtained a central or pivotal position. And this is what this picture below shows. In the middle you see the CRISIS. To the left you see all kinds of resources where CRISIS get input from, and to the right you see, all kinds of applications or systems where CRISIS function as the primary source or as a primary source of information for. So going a bit into more detail, for instance, modern CRISIS, they have automatic interfaces with external databases like Web of Science, Google Scholar, and Scopus for importing information directly from these sources, so that the researcher here does not have to type in all this information, but only has to check the information which was automatically imported, and if necessary, correct a few errors or update the information. The same goes for information, for instance, on projects which comes from administrative system, project management system, or finance administration system, or information about affiliations of researchers that is put into the CRISs automatically from the HRM systems from the institutions. And then again, only a check by the institutes is necessary, and not the inputting of the information itself. Also to the left, the internet becomes more and more an important source of information for CRISs, for instance, to get altmetrics data into the CRIS. Now, this side here, the output side, perhaps is even more interesting, since the CRISs nowadays function as a source, in a lot of cases, as a source for the open access repository of the institutions. A new thing, I will go a bit deeper into that later, is that they also start to function as sources for data repositories, so being of use for archiving data sets. An important function of CRISs is also for supplying the information to profiling applications or CV generating applications, etc. Another one is CRISs supply information to management systems, to national portals, and even to international systems or format like FIFO or ORCID. So CRISs tend to become, well, this picture, of course, is also a bit, let's say, an ideal or a future image. Not all of these things, in all cases, are, of course, already realized. But the trend is certainly there that CRISs move into that direction of being the pivot of the research information. So I already mentioned that CRISs more and more become the source for the open access repository. And more concretely, the metadata of publications, in a lot of cases these days, is primarily stored in the CRIS and then automatically uploaded to the repository system. For instance, at our institution, every night there is a web service that harvests the information that came in from the that runs from the repository to harvest the newly incoming information that day, which is of use for the repository from the CRIS. Some CRIS developers, they even go a step further and they just integrate the repository functionality in the CRIS, so that the latter also can perform the repository functions, and so replace, for instance, DSpace or Fedora. Now, a new field of application, as I already mentioned, is research data sets. In our countries, well, especially in my country, but also I think generally in Western European countries, there is a lot of attention these days on the research data, and one of the reasons for this is that some cases of fraudulent use of research data have been discovered, so everybody now wants to start a new, let's say, system of storing data, being able to control the scientific integrity of data, etc., etc. So, in this picture here, you see a bit the life cycle of a data set, where it starts with data collection, where the raw data are coming in for instance, from scanners or for telescopes or whatever. Then a selection of the data is made for analysis, repeated or cyclic analysis, temporary storage. So this is the actually research being done here. At the end, when the research is finished, the publication of results is done. There is an article or more articles coming out of the research, and also the final data sets are archived or are stored somewhere at a data hoster facility. So now where CRISIS can come in is in two places. That is already at the very start of the research. In CRISIS, you can already register the metadata for the data set, for instance, according to the DataCite metadata standard. And very important at the end, at the publication phase of the results, CRISIS are a very good instruments, very efficient instruments for linking publications to data sets and also for playing a role in the archiving of data sets. At our university, Radboud University, where we are now concluding a pilot project where we are using our CRIS to archive research data to the national data hoster of the Netherlands. And we have done this pilot with 5 research groups. They were all very enthusiastic and very positive about this model, let's say, of archiving or using the CRIS for the archiving of data sets. So now I hope that you now get more or less a picture about what CRISs are, what they can be used for. So we now can get a better understanding, get into more detail on the euroCRIS organization. Let's start again with just a few lines of history. Well, the development or the coming into being of euroCRIS started somewhere at the beginning of the 90s when research information experts from Norway and the Netherlands started up a regular communication about their CRIS developments, and this gradually grew into a European network and led to the establishment of euroCRIS as an organization in 2002. So euroCRIS is an international not-for-profit association of experts and users of research information in general and research information systems, CRISs in particular. We have offices in The Hague, the Netherlands. Our mission in one sentence is to advance interoperability in the research community through SERIF, and I will go into SERIF into more in detail in the second part of this presentation. So our main activity is the development and government of the SERIF data model and the promotion of its use. But another important goal is the promotion of cooperation and exchange of information between stakeholders in research information landscape. And to fulfill this function, euroCRIS regularly organizes international events. We have 2 members meetings every year, one in the spring and one in the fall. And we have every 2 years we have an international conference. Now our next membership meeting will take place in Barcelona within a few weeks. And our next conference will be in Scotland at St. Andrews University in June 2016. So apart from these conferences and members meetings, we also try to promote the communication and cooperation in research information by getting into strategic partnerships with what you could call neighboring organizations in the research information ecosystem. I will come back to that in the next slide. Well, members of euroCRIS, who are members of euroCRIS? Well, various organizations. We have universities, we have research institutes, funding agencies, national research councils, International Association of Universities, vendors of research information systems, publishers, etc. Excuse me. So the membership of euroCRIS, we currently have 236 members from most countries of Europe, as you could see in the colored map here, and also from some countries outside of Europe, which are listed here below. And I must say this is an old version because, oh yes, Turkey is there. Okay. Well, the strategic partners of Europe, excuse me. These are our current strategic partners. I will not name them all, but of importance, I think, and the ones you know at least are CORE, which is the Confederation of Open Access Repositories, ORCID, of which Josh Brown, if I'm not mistaken, yesterday gave a presentation. EARMA, for instance, is the European Association of Research Managers. CASRE is an international organization for setting standards in research information. And UNIS, our latest strategic member, is the European University Information System Organization. We also have CoData, APA, ALEA, which is an organization for academies, scientific academies. But again, I will not go. You can find this information on all these organizations on the internet. Now, the current euroCRIS board, we have 11 countries represented in the board, which I think is quite good for an international organization like ours. There are two types of positions in the board. We have executive positions, which are, apart from president, secretary, and treasurer, we have an executive for strategy, for communication, for events, for projects, for external relations. One who is present at the moment, I think, in the audience there. And we have one executive for academic affairs. Apart from the executive positions, we have task group leaders, and what task groups are about, I will just go a bit deeper into that in the next slides. Well, a substantial part of the work of euroCRIS is done in and by the euroCRIS task groups. What is more important is that these task groups are not just a matter of the euroCRIS board or of the organization as such, but they offer the opportunity to the euroCRIS membership to concretely participate in the activities of the organization. So every member of euroCRIS can become a member of any of the task groups if he or she wants to. In these task groups, more specifically, the members of euroCRIS work together on important issues concerning research information and the role of CRISes. So euroCRIS has the following task groups: architecture and development, best practice, TRIS, SERIF, CRIS IR, and indicators. So just a very few lines on these task groups. Architecture and development, they focus on the development of CRIS software and architectural principles, which are suitable for sharing or reuse within the CRIS community. And what they are doing at the moment is they are developing a CRIS reference implementation, which allows CRIS developers to test their SERIF compliance against, and they just have finished the work on the SERIF REST API, which is an API for exchanging information between systems based on SERIF. Best practice TRIS task group, well, they are dealing with the recording of cases of modern practice in developing and using CRISes, propagate these best practices, and assist CRIS developers and users implementing advanced concept designs and tools, and to set up an international directory of research information systems. SERIF task group, well, they are, in one sentence, what they do is they develop and they manage the SERIF data model. I will go a bit deeper into part 2 of the presentation. CRIS IR task group deals with the relation between CRISes and repositories, mainly publication repositories, but as said, also data repositories are becoming more and more important. The indicators task group focuses on the generation of best practice in the use of indicators for scientometrics, bibliometrics, indicators for evaluating research. What they did very recently is, for instance, they expressed into SERIF a set of indicators, evaluation indicators called Snowball metrics, developed by the UK universities in cooperation with Elsevier, and they are busy with setting up a catalog of indicators. euroCRIS, of course, has a website, of which you see the address here. And part of our website is also a repository where all the publications of the euroCRIS events, so the membership meetings and the conferences, go. And which you can find at the address mentioned here. As you can see, the repository is a DSpace implementation, but a special implementation is what's called a DSpace-CRIS implementation, where DSpace is enriched with CRIS functionality. One of the plans of euroCRIS is to open up its repository also for its strategic partners, so that, for instance, also UNIS or CASRE or EARMA or any of the organizations that were listed previously as our strategic partners could put their publications into the euroCRIS repository. Now, for closers on euroCRIS, you can join euroCRIS if you want to become a member. It's very simple. Just go to the website, click on this Join euroCRIS button here, and you will get a form where you can fill in some basic data, and here you see what it costs to become a member of euroCRIS. I don't think that we are the most expensive, if I may say so. So for more information on euroCRIS, you can always write, phone, or mail to the Secretariat of euroCRIS, which, as said before, is in The Hague, the Netherlands, and you can find the details here on the screen. So this concludes the first part about the euroCRIS organization. Perhaps we can give the opportunity to the audience to put some questions, if there are any. Hello? No questions? So I hope I'm still there. Can anyone give me a sign whether I'm still connected?
Can I ask a question, please? Selma Aslan from TÜBİTAK. Hello, Selma Aslan from TÜBİTAK. I have a question.
Yes, okay.
I noticed that CRIS downloads the metadata from Web of Science, Scopus, etc. Normally, databases do not allow downloading bulk data. I guess you have somehow this.
Okay, thank you for your question. Well, yes, this indeed depends on the agreement that you have with these companies. And, well, to give a very concrete example from my country, in my country, most of the universities have a license with both Web of Science, Thomson Reuters, and Elsevier Scopus, which allows them to download certain information from their databases. But you are right, you need to have an agreement with them. So, but euroCRIS as an organization does not has an agreement with these companies. So it's up to the individual institutions. Are in a lot of cases these things are of course managed on a national level to get into an agreement, a license agreement with these organizations. Yes, you're right, you need that. Okay, any more? So, okay, if there are no more questions, I'd like to go into the second part of the presentation. And can anyone give me a sign whether I'm still audible there? Is it still okay, the connection?
Yes, if you are here, you can continue.
I can continue?
Yes.
Okay, thank you very much. So, Well, part two of this presentation concerns the serif data model. So, I already briefly mentioned it in the part on euroCRIS. serif stands for the Common European Research Information Format. And that is an international standard relational data model for storage and interoperability of research information. It's an official recommendation by the European Union to its member states. It basically has two functions. So first of all, it's a reference model for the development of research information systems, CRISs. So it's a model for setting up their database, the data model. And secondly, it's a standard exchange format in its XML version for interoperability or exchange of information between systems. Now, the strong points of serif, in my view, are, first of all, it's a very broad model. So it includes almost all aspects of research information, be it projects, persons, organizations, funding information, publications, data sets, patents, products, bibliometrics, impact indicators, equipment, services, etc. Secondly, it's a fine-grained structure and it has a flexible architecture. This means, among other things, that a serif-based system is able to in as well as output virtually any metadata format used in the research information. It can also express virtually any formalized use case, and it can include an almost unlimited number of controlled vocabularies, taxonomy, thesauri, etc. in its what we call semantic layer. I will go a bit more into detail on that later. So if you put it into one sentence, you could say that serif is like a comprehensive Lego box of research information metadata, allowing you to put together all kinds of combinations of information. So a few basic principles of serif. I think I will go quite quickly on these things because they tend to become a bit technical. So first of all, only the unique characteristics of an entity are stored as attributes with the entity itself. So for instance, for person, we only store these things in the person table, and the rest is all expressed through linking entities, which I will deal with later. For publications, for instance, we only store an identifier, the title, the date of publication, and the paging info, so start and end page or number of pages. So all the rest, non-unique or variable characteristics or attributes, are expressed through linking entities between objects. And these linking entities all have a start and end date, and they are all semantically defined. This means the meaning of the relation is clearly expressed. And this way, multiple characteristics can be expressed for the same aspect. So these linking entities are really the core or a very important feature of serif. So let's go a bit deeper into that. So linking entities in serif basically are used to express semantics, and they have the following functions. First of all, express the relation and the meaning of the relation between two objects. For instance, the role of a researcher or an institute in a project or in a publication. The second function is to classify or describe objects according to a given classification scheme, like a controlled vocabulary, a thesaurus, a taxonomy, etc. For instance, classify a project or a publication according to a keyword list. Also, less trivial example, for instance, to connect the various aliases or name variants used by an author for publishing. As you know, an author, depending on the journal or depending on the period in which he or she publishes, may use various name variants. And this, in serif, you can very easily, through this linking entity mechanism, you can very easily express all these various names without getting a very big table, or without having the need to put a very big table in place. A third function of the linking entities is that it's very easy to map various classification schemes to each other. For instance, keyword lists from one discipline or field of science to another. Or another example, mapping researcher classifications used in one country to the ones used in another country. The importance of, for instance, the latter one was expressed a few years ago in a membership meeting of euroCRIS in Germany, where they had conducted a survey into the performance of various European countries when it comes to research, and they have compared full professors in one country with full professors in another country. They saw very strange results, and the reason for that was that they just took one definition for full professor and applied it to all the countries, while they discovered that full professor in certain countries meant a totally different thing than in others. So in this case, it would have been good to map these meanings to one another so that you do not compare apples with pears, as we say, but that you know that you are talking about the same things. Linking entities, as I said, all have a start and end date, so the exact time frame of a classification or a relation between objects is always known, and it's in principle possible to attach or connect an endless number of linking entities to objects. Now this illustrates the first aspect, linking objects and defining the meaning and period of the link. For instance, the link between a person and a project. In the middle you see the linking entity. In this case we have two records there. One record showing that the person in case has the role researcher in the project, and another one showing that he also has the role manager in the project. The researcher role already started in 2010, and the manager role started in 2011, the 1st of March. So by means of these linking entities, you can very specifically describe any relation and their meaning. If we extend this a bit and add, for instance, the entities, results, and organizations, you see that between all these objects there are these linking entities expressing all possible semantics or meanings as shown in gray. For instance, the person here can be an author of a publication, or a reviewer, or an editor, or an organizational unit can be the owner of a publication or the publisher of a publication, etc. So every relation and meaning can be expressed on a very detailed level. An example of classifying an object through these linking entities is shown in this image here, where you see an object, whether it's a publication, a person, or a project, can be classified by means of this linking entity here, where you see the object identifier and the classification term identifier is in this linking entity record, and also the classification scheme identifier, so which keyword list of thesaurus is used, etc. So, concrete example. We here have the case where two keyword lists, one coming from biology and one coming from medical science, is applied to the same publication through this linking entity here. And of course, as already said, it's possible to connect or link an in principle endless number of classification schemes to the same publication or the same project, etc. Last function of linking entities is to map classification schemes. So for instance, a term, mapping the terms from classification scheme A to classification scheme B, in which case the linking entity holds the ID from classification term A, from classification term B, the relation between the two, and also always, of course, the time, start and end date. If we look at a concrete example and we take these two classifications again, which we had in the previous example, we see that a record here in this linking table holds the idea of the term in one classification, in this case it says botany or plant biology, from the scheme biology subject equals to, that's the meaning of the relation, the term botany of the medical sciences subject. A result of this mapping is that, for instance, the search on a keyword from one classification will also find and display information classified by means of keywords from the other classification. So a very strong mechanism here. So all these classifications are stored in a separate part of the serif model, which we call the semantic layer. And of course, all these tables or all these objects, linking entities and classification entities are in the real world, they are tables in the database. Now, another extended example where we have put a few extra things in, like journal, indicator, measurement, etc. So you see how it can become quite an extensive model if you put a few extra objects in. And we could have done, even brought in more, like funding, data sets, equipment, etc. So in this case here, for instance, to just give a few examples of what is expressed here, person A is a member of this organization unit O. He is the head of the organization unit N. This organization unit R is in itself part of this organization unit N. The person A is a researcher but also a project leader in the project B. He is the first author of publication X, etc. So the publication X was published in a journal which is peer-reviewed. This is given by this classification link here. And there is a measurement in the database which is based on citations, and this is from the indicator classification scheme, etc. So you see how you can express a lot of information by means of this mechanism of linking entities. Now, this is the serif model. I must say, as it was like half a year ago, because of course continuously there is work in progress on the further development of the model, so a few things already have been added since. And this only shows the objects are the entities and not the linking entities, because otherwise, I mean, of course the model would explode and it would become totally unreadable. Now, for closures, let's zoom in a bit or look a bit in more detail on implementations of serif. Well, serif, as said, is the reference or base for both commercial and non-commercial research information systems. There are two major commercial ones on the market at this moment. We have one from Elsevier, which is called Pure, and one from Thomson Reuters, which is called Converis. And together they have these CRISes, they have a few hundred implementations at institutions, mainly in Europe. And the development team leaders of both the Pure and the Converis system are actively involved in the serif task group. Apart from these commercial systems, also non-commercial systems exist. For instance, IRIS from Sinica, the Italian University Consortium, currently being implemented at 65 Italian universities and research institutes. And I think Michele Mignelli, who is present at your conference, will tell you more about that in the next presentation. Also from Sinica comes, already mentioned, and used for our euroCRIS repository, a system called DSpace-CRIS. And this system extends the repository functionalities of DSpace to CRIS ones based on the serif data model. In Greece, there is a national network of serif-based CRISes established. And also, for instance, the national Slovakian CRIS is fully serif compatible. There are others, but just to name a few examples of CRIS implementations. This one's here, the previous slide, the concerned implementations of the data model as the base for a CRIS. We also have implementations of serif as the base, as the exchange format, so in its XML version as exchange format between systems. So first of all, serif XML is used in various EU projects as a standard format for the exchange of information between the systems of the partners or the countries involved. For instance, in the Engage project, which is in the infrastructure for the exposure of public information of governments of member states. Pasteur 4OA is a project for the alignment and harmonization of open access policies in the European countries. Cloud is an EU project for setting up cloud services on an EU level. And OpenAir, I think, is known to most of you in the audience. It's the European framework for open access repositories. So, examples on a national level, Greece, I already mentioned that. In Germany, serif XML is being used to supply benchmark information of research institutes to the government. Their so-called Kerndatensatz report. In the Netherlands, a few days ago, we concluded a project proposal here to start supplying information from the institutional CRISes at the universities to the Central National Research Information Portal. And also in the UK, various applications of serif XML are in preparation. So, recently published, and I think this is of special interest for the audience at the conference there, recently published were the OpenAir guidelines for CRIS managers, and these guidelines were developed in cooperation between euroCRIS and OpenAir. And as it reads on the screen, these guidelines specify the interoperability layer between CRISes and the OpenAir infrastructure. The information is based on the interchange is based on serif, the serif XML exchange format, and the OAI PMH protocol. The guidelines are intended for implementers or developers